Okay, so we completed the digital to analog conversion, that is R to R weighted resistors. So now we are going for analog to digital conversion. So for that one in the syllabus we are having class ADC, successive approximation and integrating ADC. Okay, so there is a three method we are going to study. It is very important also, that is analog to digital conversion. Okay, that previously we converted digital value that will be converted into analog. Now we are going to give you analog value, that means 3.5 volt. If you are giving corresponding digital value, it will be generated. So for that, these are the methods: single ramp, single slope, dual slope, successive approximation, flash, delta modulation and adaptive delta modulation. In this, these three methods, that is dual slope, successive approximation and flash type, these three topics are there in our syllabus. So these three is also very important also. So first we'll see about the dual slope and then successive approximation. If it possible, we'll go to a flash type. Okay, so first we'll see a dual slope ramp. For dual slope analog to digital conversion, see, this is the dual slope analog. ADC means analog to digital conversion. In the dual slope conversion, this is the diagram for dual slope ADC. Dual slope analog to digital converter. So it consists of integrator. It consists of integrator, comparator, then clock, then counter. Okay, these are the parts of dual slope. So this is the voltage we are going to give. So that voltage only we are getting as a digital output. So this is the input we are giving as an analog input voltage. The corresponding digital value will get it. So now we'll see how the analog value will be converted into digital. So first thing, first part is integrator. Integrator means it is nothing but it will be a ramp generator. Another name for integrator is nothing but ramp generator. So what will happen? This type of ramp will generate either positive slope ramp or negative slope ramp. If the input voltage is positive, it will create a negative slope. If it is a negative, it will create a positive slope. So this is nothing but a ramp generator. Now, this is the comparator. Comparator, what it will give means it will compare the two values. That means this value it is given 0, and now this is the value that will be given as an input. Suppose if the value is 0, what will happen? It will compare with this one. It will compare this one, and it both the values are 0. So what will happen here? It will produce a 0 voltage here. So the comparator, it will compare if it is 0 or 1. It will give 0. This is the AND gate. So what will happen? Here the clock input we are given. So once if it is clock input, it will be counted. Okay, it will be counted. Okay, it will be counted. So if it is 0, it is become 0. If it is 1, that means if it is 0, what will happen? The clock won't be connected here. So it will stop. It will be stopped. So what will happen? It will be stopped. So that like that it will work. Okay. So wait a minute. Okay. Okay. So what will happen if the comparator is 0, the output of the gate is become 0. Otherwise, the clock will be given to a counter. Counter we already studied. No counter, what it will do? It will count 0, 1, 2, 3, 4, 5 up to. then again it will start like that. The counter will keep on continuously counting. Okay. Then the most significant bit. LSB means least significant bit. MSB means most significant bit. So the most significant bit will be connected to the switch. So what will happen? So the switch will be previously the switch will be connected to analog input voltage. If the most significant bit is 1, so what will happen? The switch will move to a minus V reference voltage. Okay, minus V reference voltage. So now I'll tell you how the dual slope analog to digital converter. That means here we are going to give a analog voltage. For example, any value we can give. For example, we are going to give you some 3.5 voltage. So we are giving a 3.5 voltage. So what will happen? The switch will be connected here. What will happen? The ramp generator, it will create a ramp. So what type of ramp it will create means it will create a negative ramp because we are given a positive value. So it will create a negative ramp. So what will happen up to this? It will be a ramp will be generated. The time T1. So what is the time T1 means? The counter will continuously count. So at one point, the most significant bit become 1. Okay. When if the most significant bit is 1, what will happen? The switch will move to a minus V reference. So that is the point here. So this is the known value. The T1 will be known value because the clock will be it will be increased. At one point the MSB will become on. So up to that time is T1, that is the known time. So at that time what will happen? The switch will be moved to minus V reference. So what will happen if it is a minus V voltage? We'll get a positive slope. We'll get a positive slope. So first it will be negative slope. Then because it is a positive value, so we are getting a negative slope. Now it is connected to minus V reference, so we'll get a positive. So this minus V reference voltage, it is a known value. It is a known value. So what will happen? It will create a positive slope. So at one point, the value it will decrease. So at one point it will reach a zero value. Okay. So if it reached zero value, this is the output value. So now it is connected to V reference. So it is going down. So once if it is reached zero, then the comparator, it will compare. Now these two values are zero.
Hello.
So the output of the
Hello.
comparator is zero. Hello. So the output,
ഹലോ മിസ്സേ, ഞാൻ ഗോപികയാണ്.
പറഞ്ഞോ.
മിസ്സേ, ഇടയ്ക്കിടയ്ക്ക് ഞാൻ കട്ടായി പോകുന്നു. ഇവിടെ ഭയങ്കര മഴയായോണ്ട് ഇടയ്ക്ക് കട്ടായി പോകുന്നു.
That's why no problem. Okay, you just those who are having a network connection, you just listen. Anyway, I'm recording this video. I will give it in your WhatsApp. Okay, Gopika.
മിസ്സേ,
Okay. So now it
അറ്റൻഡൻസ്
is.
കൂടി ടേക്ക് ആവുന്നു. Attendance.
Attendance. I'll give it after completing this class. Okay.
Okay, miss.
So this is so what will happen at one point? You will get a zero voltage here. So it will compare zero voltage. So both the voltage it is zero. What will happen? It is become 1. Sorry, it is become 0. If the both the values are 0, same value, you will get 0. Otherwise, the comparator value 1. Only if it is 0, the comparator has become 0. So what will happen if it is 0? We are using an AND gate. So here it will become 0. That means previously the clock input will be connected here. Okay. At this point, that means at this point it is become 0. What means the clock will be disconnected. Okay, the clock will be disconnected. So we already studied the counter. It will works only on the clock. If you are not giving the clock, the counter will stop counting. So what will happen? The clock, it won't be disconnected at this point. So we'll get a digital output. So we'll get a digital output. That digital, through this digital output, we can find out a analog input voltage. So how we can calculate the digital input to the analog input? That means this digital output is corresponding to analog input. So how we can calculate means we know this is the charging voltage and this is the discharging voltage. So both the cases, the charging voltage and discharging voltages are same. So this is the two voltages. This is the charging voltage and this is the discharging voltage. So initially we are given VI, that RC constant is R1C1. Then we are connected VR. Then it will take T2 time. That time also R1C1. So both are equal. So from this R1 and R1 C1 get cancelled. So VI T1 equal to VR T2. So from this T2 equal to VI T1 divided by VR. So from this equation, what it clearly shows means the T2 was directly proportional to VI. The T2 was directly proportional to VI because T1 is the known value. Because already it told the counter it is counting. So once if MSB is become 1, it will switch to the another position. So up to that MSB, when the MSB is become 1, that value up to that counter value, it is a known value. So T1 also known. V reference also a known value. So this is the analog input voltage. So if you measure T2 value, we can find out the analog value. So how we can calculate means this is the T2 is the time, no? Now we are converted that into a count value. Okay, that we can convert into a count value. That means what? The time T2 is in seconds. Now the seconds will be converted into counts. So what we are doing, counts divided by second, it will be multiplied by T2. So now it is become a digital count value. Okay. So now this T2 value will be submitted here. The T2 value is submitted here. Okay. So this is the digital output. The advantages of dual slope analog to digital converter, it is highly accurate and its cost is low and it is immune to temperature cost variation in R1 and C1. The only disadvantage of this analog to digital converter is its speed, which is very low. Okay, so we converted the dual slope analog converter. Okay, completed the dual to analog converter.